Let's quickly recap what we know about linear functions. So linear functions are functions of this form. They are functions that take in some input multiplied by some number, and bear in mind that that number could also be a fraction. So multiplication, in this sense, we're talking about either multiplying by a number or dividing by a number. So multiplying by half would be the same as dividing my input by 2, etc. So takes in some input, multiplies it by some number, and then adds some constant to the result. That's what we mean by a linear function. And the reason why they're called linear functions is because they have a constant, either a constant increase as you increase your input, or a constant decrease as you, if your m is negative. And so when you graph them, they have graphs that are straight lines. So that's why they're called linear functions. And what we know about these functions, their graphs, is that their gradient will be whatever m is, right? So that's going to dictate kind of the steady increase or the steady decrease in your output. So for example, if m is 2, that means that your rise to run ratio will be 2. For every unit that you increase your input, your output goes up by 2, etc. And if your gradient is negative a fifth, for example, then for every 5 units that you run, you're going to rise a unit downwards, etc. So this m is the gradient of your line, basically. And c gives us the position of the line. More specifically, it tells us where the line is going to cut the y-axis. So these are all things we've seen in a previous study of functions, and very important to bear in mind as we head into this bit of analytical geometry. So what we are interested in today is being able to look at various lines on the Cartesian plane and being able to determine the equation of that line given different bits of information about it. And fundamentally, whenever you're asked to determine the equation of a line, the two pieces of information you're going to be looking for are its gradient, so any information that might help you find its gradient, and then you'll also be looking for c. You'll be looking for what its y-intercept is, or where it cuts the y-axis. The other important thing to bear in mind before we launch into a couple of examples is that the graph of a function consists of multiple points, and each of these points, each point that lies on a graph, is an input-output pair for the function that it represents. So that's something that we dwelt on for quite some time in the previous section on functions, right? So that's very important. So if you have a function like y is equal to 2x plus 1, the point 3, 7 does lie on the line, because when my input is 3, right, 2 times 3 plus 1 does give me an output of 7. So that point lies on the line. Whereas a point like 1 and 5 does not lie on the line, because 2 times 1 plus 1 is not equal to 5, right? But the point 1 and 3 does lie on the line, okay, because when my input is 1, my output is 3. So that's a very important concept as well to bear in mind. Okay, so we're going to look at a number of examples increasing in complexity. First one, we're asked to determine the equation of a line whose gradient is 3 and whose y-intercept is 0 and minus 1. So this is the most ideal situation. You've been given what m is, and you've also been told that your y-intercept is at 0, minus 1, so c is equal to minus 1. And this is very important. So if ever you're asked what the y-intercept of a line is, you can't just say that it's minus 1. Remember that the y-intercept is a point, so you have to give your answer as a coordinate. Anyway, so in this case, c is equal to minus 1. So the equation of the line would be y is equal to 3x minus 1. And you can do a bit of a sanity check. You can quickly plot this, easiest way for me looking at it is the gradient intercept method. So I'll plot my y-intercept first, and then my gradient is 3, which I can express as a ratio of 3 to 1. So for every unit that I run this way, I rise 3 units, so 1, 2, 3. So this will be another point on my line. So the x-coordinate will be 1, the y-coordinate will be 2. So my line is going to be a line that passes through these 2 points. And so let me check whether this input-output pair does actually work for this function. So y is equal to, so let's say 3 times 1 minus 1 gives me 3 minus 1, and my output is 2. So happiness. Cool. Determine the equation of the line which has gradient minus 1, okay, so you've already been given information about m, and passes through the point 6 and minus 4. So very useful to do a sketch up front. So we have 6 and minus 4 as a point on this line, and my gradient is negative 1, so it's going to be a falling line. We have a decreasing function. So I'm expecting that my y-intercept is going to be some positive number. So we need to find what that y-intercept is. What we know of our equation so far is y is equal to minus 1x plus c, right? Because remember, m represents gradient. And if we know that our gradient is minus 1, then we know that our equation so far is y is equal to minus 1x plus c, or just y is equal to minus x plus c. And so this is a function that takes my input, multiplies it by minus 1, adds c, and then I get my output. So if this is an input-output pair, that means that when my input is 6, my output is minus 4. So that's the equation that I set up. Minus 6 plus c is equal to minus 4. And if you add 6 to both sides, then you'll find that c is equal to, whoa, not 4. Minus 4 plus 6 is equal to 2. So that over there would be 2, right? So your final equation is y is equal to minus x plus 2. Righties, and if you're to do a sanity check, so we know the gradient is minus 1, which I can express as positive 1 over negative 1. If I run backwards 1 unit and I rise 1 unit, I'm going to have another point on the line. So the coordinates of that point would be 5 and minus 3, right? I'm decreasing my x because I'm going backwards, and I'm increasing my y because I'm going upwards. And so we check whether that point is an input-output pair for this function. So you have minus 5 plus 2 is equal to minus 3. That works. So these are just quick ways you can kind of check yourself. Determine the equation of the line which passes through 0, 4 and 2, 8. So now we haven't been given any explicit information about the gradient, but a useful starting point is to plot the information you've been given. So you're told that your line goes through 0, 4, right? Goes through that point, and it goes through 2, 8. Right, so something like that. So what we can see of this line is the gradient is positive, and the y-intercept is also positive. And in fact, we know what the y-intercept is, right? The y-intercept, we've been told, is 4. That's where my line is crossing the y-axis. So what I know of my function so far is it's y is equal to mx plus 4, right? And so we need to find what the gradient is. And there's 2 ways that you can go about this. You could use one of your points as it's an input-output pair to find what m is. You wouldn't want to use this point though, because the input there is 0. And so that would cancel this term, right? You'd have m times 0, which is 0, plus 4 is equal to 4. That doesn't really tell you anything. So you want to use a point like this one. When my input is 2, my output is 8. So 2m plus 4 is equal to 8. 2m is equal to 4, and so m would be equal to 2, right? So then I'd know that the equation of my line is y is equal to 2x plus 4. So that's one way that you could do it. That's not what I wanted to erase. Another way that you could do it is you could work out the gradient of the line manually. So remember that to work out gradient, we're saying the y-intercept of, so not the y-intercept, the y-coordinate of one point minus the y-coordinate of the other, x over the x-coordinate of that same point minus the x-coordinate of the other point, right? So I would say 8 minus 4 over 2 minus 0. And very important that this should represent your first point and this should represent your second point. So that would be 4 over 2, and so I find that my gradient is 2. So now I know that m is equal to 2. And then you can test when your input is 2, what is your output? Your output is indeed 8, so that works out. Determine the equation of the line which passes through 3, 7, and 5, 8. So again, a sketch up front. So 3, 7, and 5, 8. So our line looks like that maybe. So again, a positive gradient and a positive y-intercept. This time we haven't been given either of those directly, so we're going to need to work them out. The first thing that we can work out is the gradient. So the gradient is going to be 8 minus 7 over 5 minus 3. So 8 minus 7 over 5 minus 3. And that is 1 over 2. So that's my gradient, which means my line has an equation of y is equal to a half x plus c. So that's the function. Takes my input, multiplies it by a half, and then adds c. That gives me my output. So now I can take either of my points and use them to work out what c is. So let's sub in 3, 7. So that means that when my input is 3, my output is 7. And so 3 over 2 plus c is equal to 7. And if I subtract 3 over 2 from both sides, so 7 minus 1.5 will be 5.5, which is the same as 11 over 2. So my final equation is y is equal to minus a half x plus 11 over 2, right? And again, useful to check. So let's check with this point, which we didn't use to do this part. So when my input is 5, wait, why do I have minus a half here? Oh, okay. So when my input is 5, what is my output? That is the question. So we'd have 5 over 2 plus 11 over 2, which is 16 over 2, which is 8. And that is the output that we expected. There are going to be some rare cases where you might be asked to show that the equation of this line is 2y is equal to x plus 11, right? Which looks different to what we got. But all that's happened there is we've rewritten this with no fractions. So there's a couple of ways you can look at that. You could look at it by saying, well, to get rid of these fractions, we're going to multiply the equation by the lowest common denominator. So 2 times y would be 2y, a half times x would just be 1x, and 11 over 2 times 2 would be 11. So that would be one way to look at it. Or you could decide you want to rewrite everything with a common denominator. So in this case, the common denominator would be 2. And so the only thing that we'd need to rewrite is y. We'd have to rewrite y as 2y over 2, and we'd have x over 2 plus 11 over 2 on the right hand side. And so we can ignore our denominators if our denominators are the same, so that we have 2y is equal to x plus 11. So that could be another way that you write the equation. Just note that it's no longer in standard form, right, when it's like this. So standard form is when you have y is equal to something x plus something, okay, y is equal to mx plus c. That's what we call standard form. But yes, in some questions you might be given something that looks a bit different as an endpoint. So you would still start by coming here, right? So start by trying to find your equation in terms of y is equal to mx plus c, and then see if you can manipulate it by multiplying, by adding, subtracting things from both sides, to see if you can get to the endpoint that has been prescribed for you. And finally, determine the equation of the line. Oh no, this is not finally, there's one more. So determine the equation of the line which is parallel to y is equal to minus 2/3 of x plus 7 and passes through minus 6 minus 2. So again, a sketch, right? So we've got the line y is equal to minus 2/3 of x plus 7. So its y-intercept is somewhere up here, and it's got a negative gradient, so it's a falling line, right? So this is y is equal to minus 2/3 of x plus 7. And the line that we're looking for is parallel to it, and it passes through the point minus 6 minus 2. So, okay, maybe let's not quite take that off screen. So let's just say that that's somewhere over here. So my line is going to be something like that, right? Something that's parallel to this guy. And so what we know about parallel lines is that their gradients are equal. So the gradient of this line is minus 2/3, which means the gradient of this line will also be minus 2/3. So what we know of our equation so far is that the equation of our mystery line is that it's going to be y is equal to minus 2/3 of x plus something. So we anticipate that the y-intercept is going to be something negative, right? And then we've got this point that it goes through, this point minus 6 minus 2, and that is an input-output pair. So what that is telling me is that when my input is minus 6, my output is minus 2, right? And so we use that to solve for C. So we're going to have minus 2/3 times minus 6, that gives you positive 4, and your output is minus 2. And if we subtract 4 from both sides, we get that C is minus 6. So y would be equal to minus 2/3 of x minus 6. And so the quick sanity check that I would do is I'd generate another point. So I know that the gradient of my line is minus 2/3, and I can rewrite that as positive 2 divided by minus 3. You could write it as minus 2 over positive 3. So let's take this one because I think that's what I have space for. So if I run 3 units, so if I run 3 units and I rise downwards, right, so I'd have to go down 2 units, that's going to give me another point on the line, supposedly. And the coordinates of that line would be negative 3 and minus 4, right? So, yeah, I've got my rise, which is minus 2, over run, which is positive 3, so that's minus 2/3, right? So this should be another input-output pair for this function if I've done it correctly. And so I do a quick check. Minus 2/3 times minus 3 minus 6 is going to give me positive 2 minus 6, which is minus 4. And that is the output that I'm expecting. So, cool. Determine the equation of the line which is perpendicular to 4x minus 10y plus 2 is equal to minus x and passes through 4, 0. So we can't quite sketch a sense of what's going on yet because this line over here isn't in standard form. So we can't immediately see any information about its gradient or its y-intercept. So I'm first going to put that into standard form. So we've got 4x minus 10y plus 2 is equal to minus x. And remember that in standard form, we want y by itself. So I'm going to start by subtracting all the terms that have nothing to do with y. So I'd have minus 10y is equal to, well, again, I'd have to do that on the other side as well, so minus 4x minus 2. So that would be equal to minus x minus 4x is minus 5x, and would have minus 2 over there. And then we need to divide everything by minus 10. So that's going to be y is equal to, and minus 5 over minus 10 is just a half. So it's going to be a half x plus a fifth, right? That's what minus 2 divided by minus 10 is going to simplify to. So if we sketch what's going on now, we have this line, y is equal to a half x plus a fifth. So its y-intercept is a fifth. And, well, I mean, in order to be consistent with what I was preaching before, rather write that as a coordinate. So its y-intercept is 0 and a fifth, and it has a gradient of a half. So it's some line that looks like that's got an increasing, it's an increasing function, right? And we're told that there's a perpendicular line to it that passes through 4 and 0. So that would be a line that, that was such a reach. Looks like that, right? Right, so what we're anticipating is a line with a negative gradient and a positive y-intercept. I mean, sometimes our sketches do mislead us a bit, but often you can reconcile, if your answer is correct, you can reconcile your answer with your diagram. You can kind of see what you assumed incorrectly when you made your diagram, etc. But in a case like this, it's quite obvious that this is the only way it can be, right? And so if we know that the gradient of this line over here is a half, then we know that the gradient of a line perpendicular to it is going to be the negated reciprocal, right? So it's going to be negative 2. So my line, we know so far, is going to have an equation of y is equal to minus 2x plus c. And then we have this input-output pair for the line, right? We know that when my input is 4, my output is 0. So when my input is 4, my output is 0. So I've got minus 8 plus c is equal to 0. And if you add 8 to both sides, you'll get that c is equal to 8. So your equation will be y is equal to minus 2x plus 8. And again, you can kind of do a bit of a sanity check. So if your gradient is, I mean, this is the kind of thing that it won't confirm that your answer is completely correct, because, if your gradient is wrong and you use the wrong gradient to generate a point, that point will agree with the incorrect gradient. So this is just one of those things that you can kind of do in the hopes that you have worked out your gradient correctly, right? Of course, if you know your relationships between perpendicular lines, you can already check whether your gradient is correct by multiplying it with this and seeing if you get minus 1. Anyway, so the gradient of my line is minus 2, which I can express as minus 2 over positive 1, or positive 2 over negative 1. So let's go with this representation over here. So if I run a unit backwards, I'm going to rise 2 units upwards, right? So if I run a unit backwards, I'm going to rise 2 units. And so that point would be another point on my line, which would be 3. The x-coordinate would decrease by 1, and my y-coordinate would be 2. And so let's check if that is an input-output pair of this function. So we'd have minus 2 times 3 plus 8 is equal to minus 6 plus 8, which is 2. And that is the output that we were expecting. Okay, I know it said that was the last example, and then I had a brainwave while I was about to upload this video. So one more. A line passes through the points minus 1 and minus 6, minus 1 and 8. Determine the equation of the line which is perpendicular to it and passes through the point minus 3, minus 4. So again, sketches. So we have our first line, which passes through -1, -6, and -1 and 8. Okay, and then we're asked to determine the equation of the line which is perpendicular to it and passes through -3, -4. Or maybe let's do that in blue. Right? So if you're perceptive, if you're paying attention to life and its nuances, you'll see that this is a perfectly vertical line, right? And so you already know its equation without having to go into determining its gradient and whatever else. So we know that this is the line x is equal to -1. And if you still get confused about how to determine the equation of a vertical line versus how to determine the equation of a horizontal line, remember that on a vertical line, your y's are changing, right? Your y's, if you look over here, your y is different to over here, your y is different to over there. But the thing that's staying constant all along your line is your x's, right? Your x coordinate up here is -1, still down here it's -1. Your x coordinate is staying constant. So that's why the equation is x is equal to -1. And if you look at a horizontal line like this one, your x's are changing from point to point. So if you pick points at different points on your line, the x coordinates are different, but your y coordinates are staying the same. And so this equation would be of the form y is equal to some number. And in this case, if we already know that the point -3, -4 is on the line, that means that y is equal to -4, right? That is kind of the constant that my y coordinate is staying on. If you had just launched into it though and not realized that you're dealing with vertical and horizontal lines, then for your first line you would have said, well, the gradient of that line is my y coordinate subtracted over my x coordinate subtracted. So that would be 8 plus 6 over -1 plus 1, which is 14 over 0. And that is undefined, right? And the moment you see a line whose gradient is undefined, that's a line whose steepness is just infinitely huge or infinitely tiny, who knows, right? I mean, that's the whole idea behind undefined. We can't ascribe a number to it. But so undefined gradient is a vertical line, and so a perpendicular line would be a horizontal line. And you know that the equation of a horizontal line is going to be y is equal to something, right? And if your line is passing through -3, -4, then you know that the y coordinate is the y coordinate is going to tell you what number your y is equal to for all the points on that line. But yeah, let's end that there.